Hi everyone, this lecture is going to be about ggplot2 or the ggplot2 package. I'm going to talk about how to do some basic plots using the ggplot2 package and kind of what it's about. And then in the next lecture, I'll talk a little bit in more detail about kind of how it's designed and how you can make extensions to the various plotting functions. So first question, very basic, what is ggplot2? Basically, it's a package in R that you can download from CRAN, and it implements what's called the grammar of graphics, which was originally written by Leland Wilkinson and is described in a book called The Grammar of Graphics. Now, the grammar of graphics is a description of how kind of graphics can be broken down into abstract concepts. So think of the grammar of a language like English. You have things like verbs and nouns and adjectives. And so the question is, what are the verbs, nouns, and adjectives of a data graphic? And the grammar of graphics kind of describes kind of those basic elements so that you can put them together to make new types of graphics. Just like you could take a verb and a noun and an adjective and make a new sentence that maybe no one's ever heard before. You could take the grammar of graphics and put together various aspects of plots and make a graphic that no one's ever seen before. And so that's the basic idea. It's a very powerful concept to kind of organize all kinds of data graphics. Until recently, there was no specific implementation for it in R, but Hadley Wickham, who, when he was a graduate student at Iowa State, implemented the grammar of graphics as an R package called ggplot, and its current implementation is called ggplot2. So one can think of this as almost a third graphic system in R, even though it's built upon the grid graphic system, which comes with R. It's kind of a third mode of plotting that is it's become very popular. So if you think of the first mode as like the base plots using functions like plot and hist and box plot, and then the second mode as the lattice plots, so using xy plot and these kinds of trellis type functions, and then the third mode is ggplot. So you can get the package from CRAN. You can use install.packages, installs on almost all, I imagine on all systems, and you can go to the ggplot website, which is ggplot2.org. And so the nice thing about ggplot is that it is based on this grammar of graphics, and in a sense there's a theory of the graphics. So you can take this theory and kind of reassemble the different pieces to make new types of plots. And as Hadley Wickham says in his book, the basic idea is that you want to shorten the distance from the mind to the page. So if you have some data that you're looking at, and you think of a way that you want to visualize that data, you want to be able to rapidly take those ideas and turn them into a picture on your screen. So from the ggplot2 book, this sentence kind of summarizes the basic idea, but the idea is that the grammar tells us that a statistical graphic is a mapping from data to aesthetic attributes, so color, shape, and size, of geometric objects, so points, lines, and bars. And the plot may also contain statistical transformations of the data and is drawn on a specific coordinate system. So we have we have a mapping from data to aesthetics, geometric objects, we have statistics, and we have a coordinate system. So before I get specifically to how ggplot2 works, I think it's nice to kind of put it in the context of what we've talked about so far in R. So the base R plotting system has a model you can kind of imagine as like an artist's palette model. So the idea is that you start with a blank canvas, and you kind of have tools that you can kind of put on that canvas, and you kind of draw things and you plot things. Maybe you put some points and you add a line, and then you have a legend. And so you can add things one by one as you build up this little picture of data. And you typically start with a function like plot, which generates the plot, and then you add things on it when you annotate the plot with functions like text, lines, points, and axis. So this is kind of convenient in many ways. In many ways, it mirrors how we think about building plots. So often we know exactly how we want it to look. So we'll start with some data, and then we'll kind of add things on top as we build up the picture in our mind. One of the issues is that you can't go back once is to kind of modify the plot. So if you if you kind of want to take something away, you have to kind of reconstruct the whole thing. So you kind of have to plan in advance in that way. For example, one particular type of modification that's often unexpected is that you have to adjust the margins because maybe the labels you put on the sides are too big and they don't fit. Another more kind of deeper problem is that it's hard to translate specific types of graphics to others. So the idea is that if you create a new type of plot, maybe just to kind of visualize a new kind of data, and there's no way to describe exactly what that plot is. The only way to describe it is to just kind of list all the code that you use to make it, which is not unacceptable, but it's a very complex and kind of idiosyncratic description. It'd be nice if you could say, well, you take this type of a thing and you add it to another type of thing, and then you put this layer on top, and then that would be a coherent way to describe a plot. So in the base system, every plot is just a series of R commands. The lattice system is in some ways the kind of opposite of the base system. You create the entire plot with a single function call. So typically xyplot or bwplot or level plot or something like that. The system is particularly useful for making conditioning types of plots. So if you want to look at how the relationship between x and y changes as you vary the level of a third variable, z. Everything like regarding spacing and margins, that's all set automatically, so you don't have to worry about setting them specifically. And it's particularly useful for putting a lot of plots on a page. One of the problems with lattice is that it's awkward to sometimes awkward to specify an entire plot in a single function call. It may seem more intuitive to kind of add functions one by one, like in the base system. Annotating a plot is not very intuitive, and particularly if you want to annotate certain panels of a lattice plot, using the subscripts option or the groups option can be a little bit difficult to learn, especially for the beginner. And once you create a plot, obviously you cannot add to it after that. It's final. So finally, we have the ggplot system, and in my opinion, it kind of splits the difference between the base system and the lattice system. So it tries to preserve the kind of piecemeal approach where you kind of add to a plot one by one, while at the same time kind of taking care of a lot of the housekeeping for you, so the margins, the spacing, everything like that. So it lets you kind of do everything in a kind of an all-in-one model, but also it lets you annotate things by adding. So it's superficially similar to lattice, but in my opinion, a little bit more intuitive to use. And the default modes make a lot of choices for you in terms of colors and symbols and whatnot. And you can override all those things and customize your own plot, but the default's often quite useful and totally reasonable, at least when you're starting out. So in this lecture, I just want to talk about the ggplot function, which is kind of the most basic function, and it's probably the best place to start for someone who's transitioning from, say, the base plotting system. So in the base plotting system, the workhorse function is the plot function. And so ggplot, which you can think of as standing for quick plot, is kind of the workhorse function for ggplot, and it's analogous to the plot function in the base system. So one key difference that you have to get used to when you're using ggplot is that typically when you make a plot and you pass data to the ggplot function, you want to tell it where the data comes from. And the data will always come from a data frame. So a data frame is going to be, so your data have to be organized in a data frame. And then when you plot variables, those variables are going to come from the data frame. Now, you don't have to specify a data frame. You can, if you don't specify a data frame, the ggplot function or all the plotting functions will look for the data in your workspace. But it's generally a good idea to specify the data frame. That way, when you read the code that generated the plot, you know exactly where the data came from. So the data frame is very important to organize before you start plotting. Once you start plotting, the plots are made up of aesthetics and geoms. And so aesthetics are things like the size, shape, and color of things, of points, and the geoms are kind of the objects that you're plotting. So are you plotting points? Are you plotting lines? Are you plotting bars? Whatnot. One aspect that's important for the ggplot function, and also it's similarly important when you're using lattice functions, is the idea of using factor variables. So factors are very important because they indicate subsets of your data. So if you imagine you have a data frame where you have a y variable, an x variable, and then a factor variable, the factor will indicate subsets of your data in the data frame. So for example, you might have a factor that indicates the gender. So you have a bunch of males and a bunch of females. So those are subsets of your data. And you might want to plot a certain relationship divided by the various subsets. Or you might want to color certain points depending on whether they're male or female. And so the categories that are indicated by various factor variables can be useful for annotating a plot. And so one thing that's important about this feature is that when you have factor variables in a data set, you want to make sure that they're properly labeled. So it's usually not useful to label a factor variable as 1, 2, and 3. Even if you have 3 categories, 1, 2, and 3 is not particularly informative. Usually you want to label them with more informative labels so that you know what those factor variables are trying to encode. Now, the qplot function is a fairly straightforward function to use. I think it's very easy to pick up. It hides a lot of the details of what ggplot is doing underneath, which is fine for many cases. But the ggplot function is really kind of the core function of the system. It's very flexible. You can use it in combination with a lot of things that qplot can't do. So I'm going to start with a little example data set here. This data set comes with the ggplot2 package, so you can always just load it up after you install the packages, after you install the package. And so this is the MPG data set. It looks at miles per gallon for a variety of different types of cars. And you can see that in this data set from the stir that I did that there's 234 observations, so there's 234 different types of cars. And there are 11 variables that are measured. In particular, I'm going to be looking at the displacement variable, which is an indicator of how large the engine is. So this is the DISPL variable. We're looking at the number of cylinders and the we're going to look at the highway mileage, so the HWY variable, and then we're going to look at the DRV variable, which is what kind of drive it is. Is it a 4-wheel drive, a front-wheel drive, or rear wheel drive? So notice how the factors here are labeled appropriately. So for example, the manufacturer variable is labeled by the manufacturer of the car, Audi, Chevrolet, etc. And then the DRV variable, which indicates the type, the drive, is indicated with a 4 for 4-wheel drive, F for front wheel, and R for rear wheel. So a very simple plot you can make, I call this the hello world for ggplot, is to call the qplot function. On the x-axis, I had this displacement variable, which is the kind of engine size variable. And then on the y-axis, I got the highway mileage. And you can see that I specify the data frame with the data argument. So I say data equals MPG, so the data come from this MPG data frame. And so that's very simple. You can see that the plot that it makes looks very different from the traditional base plot. You see that there's kind of a gray background and there's white grid lines behind it. The points are closed solid circles rather than the kind of the typical open circles from the base plotting system. And then there are labels on the x and the y-axis. One of the things we can do is modify some of the aesthetics, so we can highlight different subgroups of the data. So one of the subgroups can be determined by, so there's lots of different cars here. Some of them are front-wheel drive, some of them are rear-wheel drive, and some of them are 4-wheel drive. So we can separate those observations out by looking at the DRV, the drive variable. And so I've specified the x and y coordinates just like before. I specify the data frame just like before. And then another argument I have is the color variable. And I'm going to say that the color is mapped to this drive variable, DRV. And all that says is that the different levels of the drive variable will be each assigned a different color. And notice I don't specify what those colors are. They're specified automatically. So you can see on this new plot here that the front-wheel drive cars are in green, the rear-wheel drive cars are in blue, and the 4-wheel drive cars are in red. And so you can see that the front-wheel drives tend to have the highest mileage. The 4-wheel drive tends to have the lowest mileage, and the rear-wheel drive is something in the middle. And notice that the legend was placed on the plot automatically, and the color coding the different levels of the factor variable. I didn't have to do anything special, and so it's very nicely kind of organized and thought out, and you don't have to do anything. Everything's done automatically. Another thing that you sometimes want to add is a statistic. So a statistic is just some summary of the data. And so the summary that we've chosen to add here is a kind of smoother, or the more technical name is called low-S. And it smooths the data, so you can see the kind of overall trend in the data set. And you can see that I do this by adding the geom argument. And the geoms that I want to put on this plot there's two types. One is I want to add the points themselves, so I can see the data. And then I want to add a smooth geom. And the smooth is this blue line that goes across, and the 95% confidence intervals for that line are indicated by the gray kind of zone. You can make a histogram with the qplot function by only specifying a single variable. So here I only specify the highway variable. and it shows me the highway mileage for all the cars in the data set. But then again, I like to kind of separate out which cars are four-wheel drive, which cars are front-wheel drive, etc. So I specify, instead of the color argument, I specify the fill argument, which says that the different elements of the histogram are going to be filled with different colors based on what drive they are. So here you can see a similar picture that you saw before, which is that the four-wheel drive vehicles tend to have the lowest mileage and the front-wheel drive tend to have the highest mileage. Another feature of ggplot is called facets, and the facets are like panels in Lattice. The idea is that you can create separate plots which indicate, again, subsets of your data indicated by a factor variable, and you can make a panel of plots to look at separate subsets together. So one option would be to say to color code the subsets according to different colors, like we did before. But if you have a lot of data points, that can be tricky to look at, and then all the colors might overlap, and it may be difficult to see the separate groups. So an easier way to do that is to say split out the three groups into separate panels and make three separate plots. So that's what we've done here. On the left side here, I've got three different scatter plots of the displacement versus the highway mileage, and then I've split it out by the different drives, so four-wheel drive, front and rear. And so you can see the relationship for these three subgroups, and it's just a different way to look at the data rather than, say, color coding the three groups. And I specify this with the facets variable. So I can, and the facets variable takes a format that's basically there's a variable on the left-hand side and a variable on the right-hand side, and they're separated by a tilde. And so the variable on the right-hand side determines the columns of the panels, and the variable on the left-hand side indicates the rows of this kind of matrix here. Now notice that in the left plot, which is outlined by the red box, there's only one row. And so there's no variable that indicates how many rows there should be in this plot. And so that's why in the facets argument I have a dot on the left-hand side. On the right-hand side, I've got the DRV variable, which indicates that that should indicate how many columns. And now because there are three levels to this DRV variable, there are going to be three columns. And so since there's only one row, there's going to be three plots all in a row like that. On the right-hand side in this plot that's outlined with the blue box, I've got three histograms. And notice that I put the DRV variable on the left-hand side of the facets argument now, so that indicates I want three separate rows. But because there's nothing on the right-hand side of the tilde, I have no column. So I just have the one column, no extra columns. So I just have the one column for the three plots. And now I've got the three histograms. You can see you can look at the highway mileage divided up by the three groups. So that's a quick example using the qplot function, using some of the data in the ggplot package. I want to go through a slightly more involved example using a data set that comes from Johns Hopkins. So this comes from the mouse allergen and asthma cohort study, which is a study conducted here at Johns Hopkins of Baltimore children aged 5 to 17. These children all had persistent asthma with an exacerbation in the past year. And the overall goal of the study was to study the indoor environment, so the home environment of these children, and its relationship with asthma morbidity. So if you're interested in kind of seeing what a little bit of this was about, we have a recent publication, and I give the link here. So here's a little bit of the max data. You can see that there are 750 observations, and I've just put 5 variables here for the sake of demonstration. One is the ID variable. The second one is the ENO. So exhaled nitric oxide is a measurement that we take that roughly corresponds to a level of pulmonary inflammation. So a large value of ENO indicates some pulmonary inflammation. The second variable here that I want to highlight is fine particulate matter. So this is dust that is less than 2.5 microns in diameter. So it's very fine dust. And the last variable I want to point out here is these mouse positive variables. So this is a skin test that the children do, which it tells us whether they're allergic to mouse allergen or not. So here's a basic histogram of exhaled nitric oxide. So this is the log of exhaled nitric oxide, and you can see it has kind of an interesting shape. It looks like there's 2 peaks or maybe even 3 peaks there as you go across the histogram. At the bottom of the plot here, I've got the code that makes this histogram in case you're wondering how you make it. And so I use the qplot function to make the histogram. Now I've made another histogram, but I've color coded the different groups, and the groups are determined by this mouse positive variable. So I've separated out the people who are are sensitized to mouse allergen and the people who are not sensitized. So the people you can imagine, you can think of the children that are sensitized to mouse allergen are more allergic, and they may be more sensitive. They have more sensitive to a variety of environmental triggers. And so you can see that roughly from the data, the blue bars are slightly higher, and the red bars tend to be slightly lower. So that suggests that the children that are mouse positive have slightly higher pulmonary inflammation on average. Another way to visualize this data is to kind of do a density smooth. So you can see that on the left-hand side, I add the geome density and to this log ENO variable. You can see that there are at least 2 peaks from the density smooth, and if you separate those peaks out on the right-hand side, notice I say color equals MOPOS, so that's I split out the colors by whether they're positive to mouse allergen or not, and you can see that the 2 peaks roughly correspond to whether they're allergic to mouse allergen or not, and so this is a nice way to visualize this kind of one-dimensional data. Now, if you want to look at some scatter plots, I want to see whether exhaled nitric oxide is related to the level of fine particulate matter in the home. And so I'm going to look at PM2.5 and ENO. On the very leftmost side here, you can see I just make a simple scatter plot of log ENO and then log PM2.5, and it's a little difficult to see exactly what the relationship might be, but we'll kind of go piece by piece here. In the middle plot here, I made the same scatter plot, but I've separated the 2 groups, so the mouse positive and the mouse and the non-allergic and the allergic children are separated by different shapes. So here I specified the shape argument, and I assign the shape to be this mouse positive variable. Now it's not really easy to see the 2 groups here. So there's one group that's triangles and another group that's circles, and because of the overlapping of the points, it's a little hard to see. So in the right-hand side here, instead of separating the 2 groups by shape, I separated them by color, and it's a little bit easier to see the 2 different groups in this plot now. One of the things you can do is to smooth the relationship between log PM2.5 and log ENO, and I want to look at how this relationship is different in the 2 groups. So I set the geome to be a point and a smooth, and rather than use low S, I'm just going to say I just want to use a standard linear regression model. So I say method equals LM. And that way I can look at the linear relationship between PM2.5 and ENO by whether they're allergic to mouse or not. And you can see that, roughly speaking, in the non-allergic children, so these amongst the red dots here, there's a little bit of a negative relationship, but it's not particularly strong if you factor in the kind of the confidence intervals there. And then within the allergic children, there appears to be an increasing relationship between PM2.5 and ENO. So another way to look at the same data is to split it out with facets. So rather than overlapping the 2 groups and then color coding them separately, I can just split them out into 2 plots using the facets variable. So the facets argument. So here I specify the facets argument, and I say I want 2 columns designated by the mouse positive variable. So no and yes. So there's going to be 2 columns, and you can see, and then I smooth the relationship within each panel. And you can see that, again, it's the same story. Amongst the mouse negative children, there's a small decreasing relationship, and amongst the mouse positive children, there's a slight increasing relationship. So the qplot function is a simple function that you can use to make very quick plots, and it's analogous to the plot function. So you specify x, y, you specify your data, and then there's a variety of options that you can choose. There are a lot of nice built-in features. So if you want to color code subsets of the data, it's very easy to do. If you want to split out different panels, that's also very easy to do with the facets. You can choose different plotting symbols with the shape argument, and so it has a lot of nice things that you can do very quickly, but that are still very powerful. The syntax for the function is somewhere in between kind of the base plotting and the lattice package. I think the graphics that are produced are very nice if you like the type of design. But if you don't, there are features that you don't like, or you don't like the design of this particular function. It's a little bit tricky to kind of modify the qplot function to suit your needs. If you want to do kind of a lower level customization of different aspects of the plot, you really have to go into the kind of the guts of the ggplot function. And that's something that I'll talk about in the next lecture.